All right, guys, so we're just going to do more practice in this video of drawing Lewis structures for covalent compounds. And so let's start with an ion this time. This will be our first ion that we have done. So this is a polyatomic ion, carbonate from your naming sheet, right? You should know that's carbonate. Well, you can look that up. That's called carbonate. And so count the total number of valence electrons. All right. Well, carbon has 4. Oxygen has 6. There's 3 oxygens. And now we're going to have to do +2. And that +2 came from the charge, right? There's a minus charge, -2 charge, so we had to add 2 more valence electrons there. So we have 4 + 2 is 6 plus 18, that's 24 valence electrons. Least electronegative atom in the center. That's going to be carbon. That's to the left of oxygen on the periodic table, so carbon is less electronegative. And so we're going to draw our skeleton with the oxygens. That's 3 of them now. On the edge, we're going to connect them with single bonds. And now we're going to try to satisfy the octet. So let's see. Let's put 2 electrons on carbon. That brings carbon to an octet, 2, 4, 6, 8. Okay, that's good. We're going to have that means 24 minus 8, 16 left over. So let's equally spread them out. 2, 4, we're counting up to 16. 2, 4, 6, 8, 10, 12, 14, 16. Ran out. Okay. And, you know, hopefully at this point you can start to see, you know, these oxygens don't look the same. We already saw that carbon is good. This oxygen is looking weird. It's only got 2, 4, 6 electrons, not octet. These have 2 in the bond, 4, 6, 8. This one looks the same, right? 2, 4, 6, 8. So those ones are good. This one's messed up. And so we ran out of electrons, so we're gonna have to form a bond here. And so I'm going to erase the carbon, okay, and then make a double bond there. Now let's count. The carbon still has 8, 2, 4, 6, 8, and oxygen has 2, 4, 6, 8. These oxygens we didn't touch, so everything's good. So that's the correct Lewis structure. Since this is an ion, people will draw something like this. They'll draw a little bracket or part of a bracket and just put the charge 2- by it to let people know, hey, by the way, this is an ion. But this is a correct Lewis structure. Now you may be wondering, like, hey, Chris, couldn't you have drawn something like this where your double bond was in a different location? Right? What if I drew this Lewis structure? Okay. And that would be totally correct as well, right? And there's even another Lewis structure, right? I'll draw it over here, where the other oxygen had another bond, or a third oxygen had the double bond. So that would be something like that. Okay? All 3 of those Lewis structures are actually identical. Okay? That's called something about called resonance structures. Okay? And usually we draw double arrows like this, saying that they're all interconverting. None of these is actually by itself the best reflection of reality. This double bond is delocalized across all the carbon-oxygen bonds. Okay? So you can think like, hey, there's a single bond, here's a single bond, here there's a double bond. Here there's a single bond, here there's a single bond, here there's a double bond. But really that double bond is everywhere. And so it's like all of these are in between a double and a single bond in reality. But that's called resonance structures. We'll get into that more later. But anyway, any one of these for now, you know, would be fine for you to write. All right, let's do another example. H2CO, right? Valence electrons, we've got 2 hydrogens, each one's worth 1. We've got a carbon that's worth 4, and we got an oxygen that's worth 6. So that gets us 12 valence electrons. Least electronegative in the center, okay? Hydrogen doesn't count. Hydrogen's always at the end, right? That's what that second rule says up here. So carbon, again, is the least electronegative. So we're going to have hydrogen, hydrogen, and oxygen at the end. That's our skeleton. We connect the skeleton. Hydrogens are already good once they're connected because that's a duet rule. They have 2 electrons. And then we connect it with an oxygen, connect to the oxygen. We have 12 valence electrons. We have 6 on the board, right? So yeah, that means we have 6 more left. 2, 4, 5, 6. Okay, let's see. Hydrogens are good. Carbon's not good. 2, 4, 6. Oxygen's good. 2, 4, 6, 8. But carbon's not good. So we have to take one of these lone pairs and turn it into a double bond. And now we will be good because we got 2, 4, 6, 8 for carbon, 2 and 2 each for the hydrogen, 2, 4, 6, 8 for the oxygen. Octet rule satisfied. And total, we use 12, right? 2, 4, 6, 8, 10, 12. So that's it. We'll just continue to do 3 more examples in the next video.